Welcome to this explainer. Look, if you're anywhere near software engineering, you've absolutely heard the massive industry buzz around Kubernetes. It's literally the engine powering the infrastructure of companies both large and small. But, despite it being everywhere, the architecture can still feel, well, kind of complex. So today, we're demystifying exactly what it is, why we actually need it, and how it completely transformed the way we handle deployments.
Okay, let's dive into this roadmap. Today, we're hitting 4 key areas: the evolution of deployment, meet Kubernetes the helmsman, Kubernetes to the rescue, and finally, what Kubernetes is not. Starting off with part 1, the evolution of deployment. We're going from physical servers straight into the container era.
Right, so to really understand our hero, Kubernetes, we've got to look back at exactly how we got here. Our industry has basically progressed through 3 distinct eras: traditional, virtualized, and where we are now, the container era. And what's fascinating is that every single era was born out of a desperate need to solve the massive bottlenecks of the generation before it.
Think back to the traditional era. Applications ran directly on physical servers, and honestly, there were no clear resource boundaries, meaning one rogue, misbehaving app could completely hog all the CPU or memory. Not great, right? So virtual machines swooped in to solve this. They isolated applications on a single physical server's hardware, which instantly gave us way better security and much-needed scalability.
But there's always a catch. VMs require a heavy, full operating system for every single instance. Containers, on the other hand, cleverly relax those strict isolation properties by actually sharing the host operating system. This makes them incredibly lightweight compared to VMs, while still giving you that dedicated file system, CPU, and memory space you need. It's the best of both worlds.
And this lightweight nature, it absolutely revolutionized the industry. It unlocks super agile application creation, reliable continuous deployment, and incredible observability. But perhaps the biggest game changer was environmental consistency. Because containers completely decouple applications from the underlying infrastructure, your software is going to run perfectly and exactly the same way on a local laptop as it does out in a massive public cloud.
Moving on to part 2, meet Kubernetes, the helmsman. Let's look at the origin and meaning of K8s.
Now, what's really interesting about this is, well, when you break your apps down into thousands of these tiny, lightweight containers, managing them manually becomes literally impossible. You need an orchestrator to wrangle them. The name Kubernetes actually comes from Greek, meaning helmsman or pilot, basically the person steering the ship through a storm. And hey, if you've ever seen it written as K8, that's not some secret code. It's just a shorthand that counts the 8 letters between the K and the S. Pretty clever.
Now, this platform didn't just magically appear out of thin air. Google open-sourced Kubernetes back in 2014, and what you're getting is the culmination of over 15 years of Google's own internal experience running these massive global production workloads, all combined with the absolute best practices from the open-source community.
All right, part 3, Kubernetes to the rescue. Let's talk about the actual superpowers of this platform.
Okay, to really grasp its power, we first have to understand its base unit, the pod. You see, Kubernetes doesn't actually run containers directly. Instead, it wraps one or more containers into a pod, which then shares storage and network resources. This is how pods actually manage the container lifecycles right at the lowest level. And this brilliantly illustrates how Kubernetes seamlessly handles service discovery and load balancing for those pods, magically mounting your preferred storage systems and smoothly handling both IPv4 and IPv6 addresses. But the true magic here is in the automation and scaling. Just imagine a scenario where a critical container crashes at 3 a.m. In the old days, your pager goes off and you're waking up. But with Kubernetes, the pod manages that container's lifecycle directly. It instantly detects the failure and just restarts the container right within the pod. And if the entire node goes down, no problem. Kubernetes reschedules the pod itself somewhere else. All of this self-healing, plus automatic bin packing to squeeze the most efficiency out of your CPU and memory, it all happens while you're fast asleep.
And finally, part 4, what Kubernetes is not. Let's dispel some common myths.
Because Kubernetes sounds like this omnipotent tool that can do absolutely everything, establishing concrete boundaries is crucial. First off, Kubernetes is not your traditional all-inclusive platform as a service or PaaS. While it totally handles scaling and deployments, it operates strictly at the container level. It preserves your flexibility by making all those default solutions completely optional and pluggable. To get specific, Kubernetes does not limit your application types. If it runs in a container, it'll run on K8s. It also doesn't deploy your source code, it doesn't build your application, and it definitely doesn't provide built-in databases. It won't dictate your logging or monitoring tools either. It gives you these incredibly powerful building blocks, but leaves the specific pipelines and tools completely up to you and your organization.
So the crucial point is, well, it brings us to this highly provocative quote right from the official documentation. Kubernetes actually eliminates the need for orchestration. I know, that sounds totally contradictory, right? It's famous for being a container orchestrator. But technically speaking, orchestration is the execution of a rigid, defined workflow. First do step A, then step B, then step C.
Kubernetes actually operates entirely differently. It comprises independent, composable control processes. You basically just declare your desired state, what you want things to look like. Kubernetes then constantly works in the background, independently making continuous adjustments to ensure your current reality always matches that desired state. It doesn't care about a rigid set of steps to get there, it just makes it happen, which makes the whole system infinitely more resilient.
So we've journeyed from the rigid, resource-hogging days of physical servers all the way to this highly dynamic, self-healing ecosystem driven by pods and desired states. It's a vast ecosystem, it's growing like wildfire, and it's got massive industry support. So the only question left for us is, are you ready to take this newfound understanding and get started with Kubernetes yourself? Thanks so much for joining me today, and I'll catch you on the next Explainer.